I think towards the end of the day, this proves to be a very interesting session because through the whole day, you have gone through a lot of aspects in the automotive, what is happening, the trends, and a lot of discussion about software, the features, the end customers, the entire ecosystem, and things like that. And that is more about very concrete stuff, what is presented to you in each of the areas. So here we have a collection of panelists who are there from the industry, actual practitioners, talking about their perspectives on the different aspects, what we pulled together. Hope this is going to be interesting for you. I'd like to call upon first Mr. Anish Cheriyan, who is Vice President at Harman. Okay. Then Mr. Kamal. Karan, he is co-founder of Future Factor 360. Then I'd like to call upon also Sreeraj Arole, who is expert in the model-based development and EVs at Wipro. And last but not the least, a very known figure to all of us, needs no introduction, Vipul Kocher, the president of ISTQB and co-founder of Verity and AiEnsured. Yeah, please. All right, so just to give a quick background of the people here, I think I'd leave all of you to give the self-introduction, starting from me. I've been in the industry, automotive industry, for about 30 years, worked with likes of Bosch for a long time, then worked at Mahindra & Mahindra, Ather Energy, and a company called Danlaw, and now I'm with Embitel Technologies, which is primarily into automotive services and engineering services for a lot of third parties, and part of the Volkswagen Group, which is where we are doing a lot of up to the cutting-edge software platforms in the under the umbrella of Cheriyan. So this is my quick background, and Vipul, of course.
Thank you. 3 decades doing this and that, and trying to figure out what is my role in all this. I am, one thing that's probably relevant is I am the convener of this conference. I think that's good enough. Thank you.
Yeah, myself, Sreeraj. I work with Wipro and main model-based software development. And as a domain, I'm mainly focused on the EV charging. Thanks.
Very good afternoon. My name is Karan Kamal, co-founder of Future Factor 360. We are a strategy consulting firm helping organizations in their globalization advisory. Essentially, we help global companies set up their tech centers in India. We've done it for the likes of Stellantis, ZF, and a few others. We also help many of these organizations in the context of their digital reimagination, which is reimagining their products, plants, people practices, and processes in the context of digital. A large part of our customer base is automotive. So looking forward to sharing some of my learnings with various interactions that I've had with some of the leaders in the automotive industry. Thank you so much.
Thank you. Hi, my name is Anish. Good evening to all of you. I hope you're enjoying the conference. I lead the global testing team for Harman Automotive. My experience is primarily around testing, cybersecurity, continuous delivery. I've spent almost 25 years in this industry. Previous to Harman, I was been working with Huawei and others. So I know what is the software-defined vehicles because we have seen the software-defined networks movement. Similarly, if you see the SDV is a similar movement. Other than what I do for my living, I also have a passion of running. I have recently published a book on running called Every Step Matters. That's about me.
That's interesting, Anish. Yeah. Thank you. So yeah, coming to the topic of the discussion, the topic broadly says role of software in the mobility. Yeah? And we have seen through the day, through all the presentations, that it is almost omnipresent everywhere, and you cannot ignore that. And it is shaping all that the new automotive is all about today, right? Let me just take a snapshot of among you, who all are into the development in the R&D side. Can you please raise your hands? Okay. Who all are into the sales side? And in the management, decision making and all? Okay. So I think most of the crowd here is from this kind of a background. So I think we'll try to bring perspectives from that angle here. And also I'd like to take one permission from all of you. We're starting this session at 4:40. This was supposed to be for 45 minutes. I hope it's okay if we spill over a little more, right? Are we okay? Okay, thank you for that. Yeah, good. So I think from the morning sessions, what we saw, starting from Lata, who spoke about the how the software-defined vehicles are coming about and things like that. Shankar spoke about the mobility in 2030, how we are envisaging it, and so on and so forth. Prasanna spoke about a very detailed approach in terms of how the model-based development is completely transforming the way software is being developed today, right? And other sessions in the afternoon we saw, and especially before this, it was not a time pass session by JP. I thought it was quite surgical to the effect that what design constraints are today and what design approaches are being taken today and what kind of a seriousness is given. I think you brought out that beautifully, JP. Kudos to you. And these are very, very strong impacting things today in the software world, because it is no longer hardware chips and components like what Damo has presented also in the afternoon. So it is taking equal space, equal volume, and equal mind share. Rather, I would say in terms of more than equal than the hardware part which goes into the automotive today. And because of that, there are so many things. One is the way the entire ecosystem itself is changing, the way the OEMs themselves are looking how to develop these things so that the customer experience is completely different, and how the tier 1 and the OEM engagement or the relationship is changing today, and how a lot of tier 2s and software startups are coming out, being a part of the ecosystem earlier who did not have any access, right? So these are all opening up today when we look at this. At the same time, when we are looking at this beautiful beast called the car today, which is coming up with something like a very flashy Sanjay Leela Bhansali film, right? Anybody has seen Hira Mandi, right? Which is the latest and greatest from, it's very flashy, it's like you see, you're dazzling to your eyes. And all his movies are the signature, where you see bright costumes, great music, and great storyline and things like that. But behind the scenes, there are so many things which happen to make it happen, right? And that is what we are going to talk about when we talk about the software in the automotive today. What all goes behind the scene? It is not just putting the features together. It is not combining a chip with a software module, but there's so much of thing which goes behind the scenes in terms of the development part, in terms of making sure all these are validated, tested, so that you get a bug-free software at the end. And at the same time, when so many complex systems are coming together, you talk of not only in-vehicle software, which has been traditional, the embedded software, which is moving towards much more integrated cockpit kind of a thing, much more HMIs which are coming, but also integrating with the cloud. We saw a session on the connectivity also as well. So it is becoming much more and more complex as we are seeing the vehicles today. So in this context, so we'll try to focus on both the ecosystem as well as the internal, some of the internal aspects, what we see are the challenges today. So to start with, I'd like to ask Karan. Karan, from your point of view, you have been interacting with a lot of companies and then trying to connect them, and then you're into consulting game. So how do you see this industry shaping, especially the software changes? Can you please simplify for us, because the SDV, when we talk software, we talk, there's so many complex things which come across, right?
Absolutely. Thanks, Sirish. In the past, we've actually seen, a lot of software-driven components in the context of a vehicle. But what we are really talking about now is what we call as a software-defined vehicle. Let me tell you what software-defined vehicle is not. It is not an existing software functionality that's been loaded into the vehicle that you can activate on a subscription basis. It is not just over-the-air updates. It is much more than that. What is it really? It is the expansive capability that a vehicle can offer for a function that has not been shipped yet. What do I really mean by that, right? So typically, when a new functionality has to be implemented in the context of a vehicle, it takes anywhere between 1 to 5 years to make it productionized. But however, with the construct of a software-defined vehicle, we are looking at these functionalities being enabled in months. And how is it that that such a thing is being made possible? It is in the way the vehicle is being architected and engineered, which is a fundamental reimagination from what has been done in the past. In the morning, we had a few of the stakeholders talk about a software-defined vehicle being a smartphone on wheels. But the way I see it is a little different. I see it as, and even this is something that Bosch talks about as well, they call it a living habitat on wheels, because, or an intelligent habitat on wheels, because a smartphone just gives you a limited set of sensory experience, but a living habitat on wheels, which is a software-defined vehicle, gives you a multi-sensory experience, right? From infotainment to comfort to the driving experience, right? So these are some new possibilities that are being created by a software-defined vehicle, but it has its own complexities. And we'll have some of the panelists talk about what those complexities in detail are. But the complexity really is the fact that in today's vehicles, you have the different domain ECUs, about 100 domain ECUs, which are not scalable. The processing power is limited. There is limitation in terms of low latency communication. A lot of this needs to be addressed for us to really look at a vehicle that evolves as the functionalities evolve, or to implement functionalities that have probably not even been imagined as yet, right? So this whole paradigm is creating a lot of complexity in terms of development, in terms of testing. So I think we should probably have some of the experts talk about what these challenges really are.
Yeah. So thank you, Karan, for that perspective. And I really agree with you because there's a lot of comparison which is happening between smartphone and a car. But I also second you, it's not apple-to-apple comparison at all because like what you rightly said, your car is a habitat which is there. Just very elementary differences. You carry your smartphone with you, but the car carries you. You are a part of the car, right? So that changes the whole scenario altogether. So in your smartphone, you can afford your software to crash, your electronics to fail, your camera can glitch, absolutely no problem. But on your car, if any of these things happens, your software glitches, or if your cameras, which are the ADAS sensors which are sitting there, if they glitch, you are into fatal situations there. I think this is the fundamental understanding and something which has to be ingrained into every person in the industry, that you cannot simply say a software is sitting there, software is sitting here, and it's one and the same. And in that context, it becomes all the more complex to make sure the reliable software goes out, and a lot of things go behind the scenes. I would request Anish to throw a little light on that in terms of how do we make this more robust, more reliable, more dependable when all these features come out.
So maybe I will share my perspective about, of course, the good thing is that a lot of context has been already set. To me, like, 4 things are pretty important in this whole value chain, right? The first one is the number of ECUs which has come in, right? There's a proliferation of ECUs which is doing the right stuff, right? Sending the information and so on. So that's one of the big game changer around it, right, with respect to this. Now, once we have this, a lot of information. How do we process? The second part is the car itself is a computer. It is a computer in itself. And how do we manage that, right? The vehicle computer, that's the second part. The third part is, if you see, how do you interact with your car, right? It's more of like a mobile for you, right? How do you have the same seamless experience, the mobility around it, right? Whether you're using whatever phone you're using, the infotainment system around it and so on. That's the third part, which is also a game changer because car is an extension of your living room, is some the habitat which we talked about, right? And the fourth part is, you can guess it, right? The whole change around the cloud and the surrounding system around it, right? The how do we communicate the information through the cloud and the protocol development around 5G and so on, right? And of course, the communication to vehicle to infrastructure, because this is happening because the whole protocol around this has changed. The technology has changed around it. So the key point is that how do we see all of these things together? Number one, how do we, as I think JP rightly mentioned, how do we architect the right solution around it, right? When we have this kind of, central compute kind of a solution, how do we have the right architecture? And of course, the testing, the safety, the cyber security test around it and so on, which we need to talk about. Of course, we can get into more detail when others cover the perspectives.
Thank you, Anish, for that. And what you rightly said also in terms of the ECUs versus now, the whole trend is moving. Earlier, it was all distributed ECUs which were handling different functions and say whether window lifter, separate ECU, infotainment, separate ECU, and so on. And there was a next generation which is moving to domain controllers where you divide the front domain into one group, the back domain into one group, the engine and the performance drivetrain domain into one group, and so on. Now we are seeing a lot of convergence happening in terms of central compute. There's one single massive computer sitting which is doing almost everything. And with that, the kind of failure modes, what you can imagine, the complexity in the software which goes, it's I think anybody's guess, right? So in terms of this also, when you look at the development, the way the development has been happening earlier, all the ECUs were following hardcore embedded programming using C or any other languages which is suitable to them. And then when it came to the domain stuff, you started talking about the functions and the modules, function libraries, and so on. And now with all the domain computing which is coming, central computing which is coming in, we are seeing a lot of more model-based development which is coming in. Perhaps Sreeraj, you could throw a little light in terms of how this whole thing is changing and evolving, and how do you see the future in the implementation side of it?
So when we say about the model-based development, so at this stage, at this present, before this transformation, we are at a mature level from where we evolve from a hand coding to a purely process-based model-based design, where we define different model components that are traceable to exact requirement, and that to the functions that are verifiable, modular, repeatable, all of this. And next transition, when we say to the software-defined vehicle, as everyone said, it's mainly about the architectural revamp. Because when we say about the existing architecture, it's a tightly coupled monolith. So where we have different AutoSAR standards, because safety is paramount. So when we define a right code for an ECU, that has to be 100% reliable. And if there is a failure, that should be mitigated to a minimum, to minimal level. So currently, when we have a model-based design and AutoSAR architecture that's running on the legacy software, and now if we want to move to a software-defined vehicle, how we can revamp the architecture and how these processes can support throughout the journey. That's the current, challenge, as well the innovation going in. Like how we redefine this architecture into a new method, how we do different verification process. Maybe, on the coming session, you will discuss about more on that.
Thank you, Sreeraj. And very interesting part, what you said, the software is getting decoupled, but at the same time, if you observe at a macro level, the hardware which was earlier distributed is getting tightly coupled now as centralized computer. Software which was earlier tightly coupled is completely getting distributed, modular, and so on. I think this is an inverse relationship between these two entities, hardware and software, which is happening in the industry, right? Now, with all this happening, you spoke about the model-based development, which enables faster time to market, perhaps, and also reusability, which increases with all that. At the same time, when we talk of developing the models and having function modules and libraries as a part of your entire development ecosystem, right? There's also a whole lot of thing which goes under how do you pull these things so that you can plant these on the respective ECUs and then get the desired functionalities out there? And how do you test it on a continuous basis? That's where I think we're also seeing what is happening on the cloud side, which is we call the CI/CD approach, which is also penetrating deeply into the automotive development area. Perhaps Anish could talk a bit about that, yeah?
Okay, this is one of the, most easiest and the most complex thing about this whole stuff on continuous delivery. The good news is that everybody is adopting it, and the bad news is that we are not adopting it in the right spirit of it, right? So if you see, right, the continuous integration or delivery has a couple of aspects, right? How do you see the system, right? As I think Sreeraj rightly talked about that overall, what is your system architecture? What's your overall software architecture which you are talking about? How do we build the CI architecture, first of all? I think this is something which most teams miss at the beginning, right? When we are we really componentizing our system according, if you have multiple different systems, do you have separate CI systems for it? How do we set a build pipeline for it and so on, so that your CI systems are more faster? Now, why I'm bringing this point? Because finally what we have to do is that moment a developer is checking in the code, you want a very fast feedback, right? Because if you have to have a turnaround time of 6 months or 1 year delivery, you have to divide this into multiple sprints. If you have to do that, your CI system should be faster. And if it has to be faster, you need to really decouple it, componentize it, run it effectively, right? So the key point is that how do you ensure that your CI systems are organized in a way so that your pipelines are more faster, you run all your tests in an organized manner, and finally when you are releasing it, your system should be able to release on everyday basis, right? At any point of time. Today, if you see, there are multiple OEMs in which we are working, they are asking for daily releases. I mean, gone are those days when we are looking for 6 months one release or 3 months one release, right? There are daily releases which are expected. For that, your CI systems need to be designed in such a way so that it's scalable. We can talk more about it, but the key point is that it's very important that when we are talking about continuous integration or continuous delivery, the whole design of the CI/CD system has to be done in a more holistic manner. We can talk more in detail as well, yeah.
So as these complexities are growing, so what you rightly said, the focus on architecture is not just on the development part, but your test systems, the whole test strategy, and also has to be architected very well. And Vipul, I'll request you to shed light on this because you have extensive experience in the testing area through your history. And how do you see these things changing? And where is this all heading now?
Guys, every film has to have a joker. I'm the joker of the pack. So I will start with the joke. I don't know whether it's a joke because my memory has grown foggy, but the joke goes like this, which could be factual thing, that Bill Gates is supposed to have said that if you developed cars like software, then you would have a mileage of 100 kilometers to a liter and so on and so forth. And the car manufacturer guy, whoever, said, and we would have a car crashing 10 times a day. To today, where we are talking about software defined vehicle and so much, it's a huge change that has happened. For many of you who are young ones, probably this is not so much of a change. But when I look back, a software which used to crash, Windows used to crash every now and then. Basically, the moment you started looking at it, it would crash. So why did it crash, and why will it not crash when it is now, the current breed of software that goes into the vehicles is a big question. And interestingly, we need to go back to the fundamentals from a testing perspective. We don't need a whole lot of new techniques and technologies. All we need are fundamentals, and unfortunately, fundamentals are not known to most people. We don't really care much about fundamentals. So that's one aspect. If you do what you know well, you'd be able to do a good job. That's one aspect. If you look at the standards and are able to fulfill the spirit of standards, especially from safety perspective, then another aspect is covered. If you start looking at security right from ground up, then another aspect gets covered. But what we are not talking about is what is going to happen tomorrow, which is AI. All that was fundamental. Same techniques can be applied. What you apply to embedded systems, what you apply to even software, you can apply there. But same things, the rules change the moment AI comes into picture. And like it or not, we are talking today about all these different things, but the software we are talking about is conventional software, right? The moment more and more AI starts to get into your car, non-deterministic, probabilistic system, it creates all the set of challenges. The amount of data that you can use to test it, it creates all sorts of challenges. So what I see happening is, and there's a big problem that I foresee, which is reliance on CI/CD. Somebody has to be joker, right? Why? Because the whole idea, whole assumption that you can automate all sorts of tests and you don't need human beings to look at it is preposterous, ludicrous. Do you want one or two more such words? Because the belief is that tests are static in nature. We have already understood what needs to be tested and we'll keep running those again and again and again. But that's not the case. Things change with the, over a period of time. For example, tolerances change, environmental conditions change, vehicles, especially mechanical parts, they undergo wear and tear. And what happens in many such cases, you need to basically then probably change your tests and so on. And last thing that I'd like to say, this is even longer history. I don't remember, I wasn't really born there, so I just read this, that one of the directors of NASA had a big minus or plus sign behind him, just that on a poster, because of that one sign change from minus to plus. The rocket that was supposed to go, let's say, towards the moon actually went towards the sun, and then you can imagine what happened and so on. So again, we go back to fundamentals.
I think fundamentals need to be really strong. That is there, and never undermine the joker, because within the circus where each and every specialist is there, joker is the one who knows everything. Okay, I think we'll take a pause here and open it to the audience. If you have any questions, we can have an interactive session and then continue with the next part of it. Yeah.
So one question that I have is, everybody keeps talking about AI for productivity, AI shortening the timelines for testing, etc. Right? AI is also proving very, very sort of like able to hack systems, and also potential threats it's able to unveil faster. And I mean, there are obviously going to be malicious actors out there who are going to start using AI to start hacking into your system. So what sort of AI in testing, from even with SDV's perspective, right? What sort of threat potentials and so on you can start thinking about using AI for?
I think it's a wider part. First, I will answer to Vipul's point, right? See, I think he brought rightly the key point, right? The CI/CD, what are we running in the CI/CD, right? CI/CD cannot be a buzzword. I said it's the good thing to happen, and the bad thing is that we are not implementing it correctly. So the problem is that, what do we run in this, the right test suits? So now coming back to your question, is that, how are we utilizing, I mean, finally at the end of the day, whether you use Copilot or whether you use ChatGPT based or Llama based, any of those generative AI based application, the key point is that you are asking certain, commands and then getting the test cases which are from the repository and it generates, yeah. But finally, if you just copy paste that same test cases and put that and, wrap it around and build on top, it's not going to work out. The key point is that, are you using the right techniques around? For example, the stride technique, we say spoofing, tampering, repudiation. Look from your attack vector, from each of the entities, look into from each perspective and see that what are the different threat models that can happen around it, identify test cases around it, and see that, and then you see that from the generative AI, what test cases you can utilize for that purpose. But it cannot be a blind utilization of, okay, if for a particular threat model you just directly use it, it doesn't work that way. That way I think it's a recipe for disaster. So the point is, for any system which you wanted to make it cyber security wise safe, you need to ensure that do the right threat modeling, use the right test design techniques around it, and then you look for whatever you can generate from generative AI or whatever that comes out from that, yeah. So back to Vipul's original point, do your basics right. The basics doesn't change, right? It's like we are talking about computers in 1990. Whatever we say, computers are there. We cannot ignore it. But the point is, if you use like a dump, you cannot change. So AI has to be used in an intelligent manner.
If I could just add to that, right? So the way a lot of the OEMs are looking at this is, of course, there is the huge potential of SDV in terms of the incremental revenues that it can add, right? $650 billion by 2031 is what the estimates are. Plus, in terms of driving the customer experience. But from an OEM standpoint, it can actually bring in a lot of efficiency, flexibility into the product development process itself. And what is being touted is that some of the verification validation would be simplified in a way wherein the code to road timelines will be significantly reduced. With your virtual development, your drive tests are reduced, right? So with the ability to get the data of the vehicle on the ground, there is more inputs in terms of how you can test the vehicle. So there is, in a way, the whole construct of the SDV is feeding into bringing in efficiency into validation and verification process.
I think it's a very important question and very close to me also. So I will just say a couple of things right in this, is that one thing which if you see, if somebody has worked in the at least 10 years back in the automotive industry or 5 years back, one fundamental thing that is changing is that we are focusing on a lot of fast running test cases. And if you see today into a test suite, any test suite, if you go back and check how to identify fast running, any test cases which is taking more than milliseconds, those are typically not unit test or API level test. API level test or unit test should give feedbacks in seconds or milliseconds. 70% of your test cases should be around that. Go back and look into your test suites. High chances are there that almost less than 30% of those test cases are around that, and 70% are long running test cases, which is taking minutes. So one fundamental change in the verification and validation that should happen is that look into test cases which can be written more at API levels, more simulations rather than waiting for the actual target hardware and so on. This will be one thing which we are working on it very heavily. I'm seeing a lot of OEMs working on it. The second one, very other important change, which is that a lot of OEMs have their own internal software houses, and they're also working with tier ones and so on. They're expecting us as tier ones and also within their OEMs to set up their own CI systems where the test suite should be integrated. So whichever team you come from, because in verification and validation there are many teams, right? Integration team, system testing team, hardware testing team, validation team separately for thermal testing and so on. As much as possible, ensure that all those tests are automated. Good quality automation, please set up test review boards to ensure that those test cases are good quality, because otherwise it's like, there was a story about, there was one guy in that film, they say that, that Gorkha keeps saying that jagte raho, jagte raho, jagte raho, and everybody is kind of, away, very happily living, and sleeping. But the one fine day the Gorkha dies, and they realize that the Gorkha could never see, The fact is that it gives you only a satisfaction that your test is passing, but actually your production code has problem.
The system is not designed properly or system is not tested properly. In my experience, the root cause, what I have seen is the absence of the proper requirements. So if the requirements not are proper, the system will also not get tested properly. In automotive world, what I have seen is because of the lack of time or what, the system requirements are not specifically hierarchied. That means you have a system requirement high level, low level, and then software requirements high level, low level. So in this whole process, you are missing the requirements which are supposed to be designed or which are supposed to be tested. So what is your take on this? Because tomorrow if you find any field issue, I should be able to link to any of this requirement which I am not seeing it currently.
So you're coming from the traditional world of the waterfall model, where everything is defined up front, and things have changed drastically in the automotive world today. Everything is following so-called agile, where it's iterative development which is happening. It's a blend of specifying the requirement, at the same time discovering the requirements on the fly. So that is what is happening nowadays. Correct me if I'm wrong, right? And this poses a complex challenge, because what you said is right. Traditionally, the way we have been used to developing, knowing requirements and exact design for that. But the challenge in the automotive industry now is today is the incubation cycle which is required for coming up. Let us say you're planning a new vehicle platform, new features and things like that. Minimum 2 to 3 years is the lead time for that. And by the time you're clear with all the requirements developed, that the market has moved ahead. And that is where the SDV comes as an enabler for you to give this flexibility to keep on changing, upgrading over the OTA and developing new features, pushing it, and then testing them offline in an iterative manner. I think this is a fundamental change which has happened. Yeah.
So in traditional or in agile, say at the end of the day, we should have a right set of requirements. Do we feel that we have a right set of requirements for any of the programs we do?
I will take this in a different perspective. I think you're right. Irrespective of whether you are in SDV, this fundamental problem is there on requirements engineering. See, in my view, right, again, I think we're in an interesting time where our past good experiences, whatever experiences or whatever good things we have achieved is also a burden for us today. Why a company like Tesla or some of the modern companies like NIO and others are able to so quickly ramp up is because they are starting everything afresh. Whatever problem is that SRS, like CRS, SRS, TRS, and then giving it to the smallest unit and so on. I think, like he rightly mentioned, I think it's not about sometimes going at that level of detail sometimes. Sometimes it's all about discovering. But the point is, there are one section of team within our organizations who want to work in an SRS, CRS, TRS way. And there is another section who want to go in agile way. Even OEMs are themselves confused between an agile world and a waterfall world. So
irrespective of whatever, the key point is that how do we dissect or decompose our requirements to the granularest level from a customer's requirement to those, whether you call it story or TRS, whatever that is, how do we take it to the granularest level, right? That process is the requirements engineering process, and cannot be done by one team sitting in some corner. There has to be shared understanding. Agility is all about bringing shared understanding between the requirements engineer, architecture, developers, and testers. There should be less handoffs. Unfortunately, historically, we have been working like this. Requirements engineer will write requirements engineering in DOORS or DNG. Architecture will define the architecture. Then they will be given to design, and then they will go into the developers. And the developers and testers will be done doing the things separately. These things has to be, I would say, level setted now. I think a lot of improvements are happening across the organizations, and more innovations are required around it. I think this course which I saw, I think that's something which I was also talking about, that whether requirements engineering architecture has to see things together. It's a long answer, but we can connect offline and discuss more aspects on this. Thanks.
Everyone, and that was quite a interesting discussion. I hope you all liked it and enjoyed it. And yeah, there are a lot of more topics which can be discussed, but because of lack of time, I think we can keep it for the next session. Yeah. So thanks everyone, and yeah.
Thank you.